You spend 4 hours copying notes directly from a textbook, only to end the night staring at a blurry, towering wall of text. You find yourself reading the exact same paragraph 3 times in a row, yet the information refuses to stick. This leads to a specific kind of failure in the exam hall. You look at a question you know you covered, but the answer remains locked behind a mental fog. This frustration is a symptom of treating the human brain like a single-lane highway. When all your study data is forced through one route, you create a massive traffic jam in your working memory. Forcing 100% of your material through a linguistic, text-only channel overloads your processing bandwidth. Cognitive load is the total amount of mental effort used in your working memory. When it's maxed out by dense text, information stops moving into long-term storage. Doubling down on text-only notes won't help. It only increases your cognitive fatigue and makes it harder to retrieve those facts when the pressure is on. To bypass this bottleneck, you must open a second parallel highway for that information to travel. This is the logic behind our 14th technique, dual coding. Dual coding deliberately combines text and visuals, providing your brain with 2 distinct pathways. This simultaneously engages both the text and image processors in your brain. These parallel streams lock together at the end, creating a reinforced mental model where both support each other. Memory works as a network of interconnected nodes. By encoding data through 2 separate channels, you provide your brain with multiple retrieval paths to the same piece of information. To see how this works in practice, consider the experience of eating a traditional Kathiawadi thali. Text-only notes are like eating dry roti by itself. It is difficult to consume, hard to swallow, and lacks the variety needed to stay engaged. Your visual notes act as the sev tameta nu shak, the vibrant tomato curry that provides the flavor and makes the meal complete. Combining the roti and the shak makes the meal easy to digest. Similarly, combining text and visuals makes complex academic data easier for your brain to process. The workflow is straightforward. First, read the textbook paragraph to identify the core concept. Once you have the concept, stop writing exclusively text notes. Instead, synthesize the data by drawing a mini timeline, a basic graph, or a simple icon next to every key definition. Comprehension happens when you translate a string of text into your own personal visual vocabulary. Let's look at a standard geography topic to see this in action: the water cycle. The common mistake is to write out a dense paragraph of text to define a word like precipitation. Using dual coding, you write the word precipitation and immediately sketch a small blue rain cloud right beside it. This doodle acts as an anchor, linking the abstract term to your spatial memory, the brain's resilient system for recording the layout of objects. Now imagine you are in the high-pressure environment of the final exam. Under stress, your linguistic memory often falters. The exact textbook sentence you memorized might vanish, but your visual memory is much faster to trigger. You will likely recall the image of that blue cloud icon first. Recalling that visual anchor provides a direct path back to the text data it was attached to, allowing you to reconstruct the full definition. Many students hesitate here because they feel they aren't artistic, but artistic skill doesn't affect the cognitive benefit of this technique. Basic stick figures, simple thick arrows, and even emojis are effective, as long as the symbol has a clear meaning to you personally. To keep your study sessions efficient, limit your visual notes to just 2 or 3 colored pens. Your notes are a tool for retention, not an art project. By engaging 2 channels, you create a more reliable retrieval system for your next exam. Stay tuned, because in the next video, we're looking at how a growth mindset can change your entire approach to difficulty.